Alright, so today is going to be an interesting topic that I'm going to discuss. You might have heard about Singleton design pattern, right? You might have implemented Singleton design pattern in your application. You might have read about Singleton design pattern somewhere, right? How about relating Singleton design pattern with a real world analogy? That's what I'm going to do in this video, okay? Do give this video a watch until the end and I'm sure you will find it very interesting, okay? Let me make it very interesting, okay? Now before I make it interesting, there's one boring bit here, okay? I'm going to read out the textbook definition of Singleton design pattern, okay? It says Singleton design pattern ensures a class has only one instance and provides a global access point to it, okay? It controls object creation and offers a centralized point of access, okay? Too many words, okay? Let's try to just focus on the highlighted words. Only one instance, right? Provides a global access point, right? So this, I'm imagining this some global one single point access that it offers. It controls object creation. So that means no more than one object can be created, okay? And it is controlled, right? Centralized point of access, which is pretty much the same as global access point, right? Now it has too much theory, right? Let's get into the analogy. Imagine you're walking up to the bank, okay? Generally in government banks, let's say when you walk up to the bank, the first thing you'll realize is there is a pen kept at the counter, right? At the bank counter, and that is tied to a chain or even a string. A lot of times it's a string, right? In India, you'll find pen tied with some kind of a string, right? Now let's see how this is related to Singleton design pattern. I would say this is exactly Singleton design pattern, right? Let's see how. For every customer visiting the bank, there is only one instance of pen available for them to use, right? How are you ensuring it? By tying a chain or a string to it, right? As simple as that. This is nothing but Singleton design pattern. You are ensuring that the object is limited. There's only one instance of pen available throughout, right? Now let's try to understand the problem statement that they would have been trying to solve in the case of a bank. Everybody walks into the bank, right? And unfortunately they have to fill up some kind of a form to do some kind of a transaction, and a lot of people do not bring pen with them, right? This is a problem statement. Now let's say the bank employee gives all the customers the pens, right? Think that the bank employees offers pen to everybody that walks into the bank. That's going to be very costly, right? The bank has to purchase those many pens and give out to people, right? And people can take away, right? So that is not the ideal scenario. The bank still wants you to fill up the form, right? But at the same time, the bank does not want to spend too much money on pens, because as such, the bank is not dealing with pen, right? What has bank to do with the pen, right? It cannot source those many pens. It cannot procure those many pens just for the sake of customer, right? But it still wants customer to fill up the form, right? The best way to solve this problem is buy one pen, just buy one pen, right? And tie it with a string so that nobody takes it away. Your pen is secured and you're ensuring that it is singleton. Only one instance of pen is available. As simple as that, right? See, right? Now let's try to discuss some limitations of this design pattern, right? It is generally considered as anti-pattern in software engineering, but you have to make the right judgment to use this, right? I won't say just because this is considered anti-pattern means that it should not be used, okay? Where would you use Singleton design pattern? There are definitive use cases that you will use Singleton design pattern, right? So let's understand what are the limitations of Singleton design pattern. The first thing is concurrency. Now in terms of software engineering, okay, concurrency issues. Two or more threads accessing the same object at the same time would lead to thread safety issue. Okay, so there's something called thread safety issue. Imagine 2 or 3 threads operating on single object at the same time. Okay, now how best can I explain this in the analogy? 2 or more people accessing the same pen at the same time would lead to conflicts, right? There cannot be 2 people who are using the same pen, because at the end of the day there's only one pen, right? So this is a problem, right, which you have to somehow resolve. So this is again a problem in software engineering, right? The second one is lifetime management, wherein memory leaks may occur if singleton lifetime isn't managed carefully. If it is not managed carefully, there will be memory leaks. Okay, now let's try to understand with respect to the analogy. Risk of pen damage due to inconsistent handling by different customers. Imagine every customer handles the pen differently. Okay, some people might want to force the pen to write something. Some people might not handle carefully, right? There's always a chance that since so many people are using the pen, inconsistently handling the pen, it's more likely that the pen might get damaged, right? It is almost analogous to memory leaks, right? If too many people start operating on some object, single object, and if there is a problem, there can be a memory problem, right? Now the next thing is global state complexity. Challenges arise in managing shared state across the program. Let's try to understand the analogy here. Difficulty in coordinating pen usage among multiple customers. Now there might be a problem wherein there are so many people standing on the queue just to use the pen, right? Now when you make it global, when you make it such that there's only one instance available, that means it becomes a little difficult for you as a bank to coordinate between multiple customers, right? You have to still ensure that every customer uses the pen, but the thing is you have to keep them waiting for a very long time, right? So that's another issue that you have with singleton design pattern, right? Now let's just see the application of singleton design pattern. This is an implementation of singleton design pattern. So one of the applications here is logging. Okay, now this is with respect to software engineering, like where would you apply singleton design pattern? So logging is one of the predominant use cases of singleton design pattern, and this is a simple logger which is written in C#. Okay, so take this logger. Okay, logger, there is an instance, and see that this is private. Okay, the variable is private, it cannot be accessed from outside. And there's another thing called static. Now static is like that chain that is tied to the pen. Okay, just keep that in mind. Private logger, this is interesting. See, the constructor itself is private. Now this is an implementation, I'm just talking about the implementation, right? The constructor itself is private. That means you cannot access this constructor, or you cannot create an object of this class from outside, right? It is not public, right? Now what is public here? Public static. See, the class actually has a static method which returns the same type, which is nothing but the logger, right? It says get instance. The first time the instance is not available, so first time the instance is going to be null. It is going to instantiate from within this class, and then it is going to return you the instance, right? Now once this is initialized, every time this get instance is called, it is going to return only one instance all the time, because this is no longer null, right? And then when you say public void log, you are going to log something over here, right? Just to make sure that it is the same instance, you have a log method, right? Now how are you going to use this? You are going to not create an instance this time, right? Instead, you are going to request the instance, right? You are going to request for the pen, right? Imagine you are requesting for the pen, right? Now every time you are requesting for the pen, you are just getting one instance of that pen, right? And then what you're saying is logger.log, this is a log message, this is another log message, everything is operated on the same instance, right? There's no two different instances at any given point in time, right? So this is a very simple implementation of singleton design pattern, and the application is logging, right? What are the other applications of singleton design pattern? Database connections, right? And network or IO operations. So typically what you would do is you would create one single object of a database, so that you need not open the connection one more time, or you need not open the connection again and again. So every time you are making a transaction to the database, the connection will be always open, so that you need not have that additional delay, right? You want to save that time, right? So it is used for that, and it is also used for network or IO operation. Let's say if you open a file and if you read or write something onto the file, generally you would open the file only once, and whatever you want to read at once, whatever you want to write at once, you are going to write it at the single, using the single instance, right? Caching. Now every time you cache a data, right, that is nothing but like a singleton, that follows a singleton design pattern, right? Every time you need the same instance of that object. Let's say you are caching the user object, you are caching the session state, okay? It will just be the single object available throughout the application, right? There is not going to be more than one object available to the application, right? This is all I had for singleton design pattern. I hope you liked it. I hope you liked the analogy. I hope you are able to relate it with the analogy that I described just now. And until I see you the next time, take care. Bye.